Hey, my friends, welcome back. This is CSE 1321. That is a total lie. This is CSE 1322. And this week we are in lecture number 18, and we are going to be dealing with module number 7. This is going to be the only lecture this week, and it's actually a relatively short one because it's just a single topic. So what we're going to be talking about today is FileIO. So that's going to be fun and exciting. We're going to do a couple of cool examples here. There is, logistically, you guys are probably wondering when you're going to get your grades back for test 2, and I can tell you that grading is ongoing, so I don't expect you will have an answer this week. You're probably looking at sometime next week at the earliest, and I think even that might be ambitious. We'll see. But anyway, so we're certainly going to aim to get them back to you sometime in the next couple of weeks. All right, so that's what's going on there. Hopefully everything is going well for you guys and that you're making progress with all of your labs and assignments and whatnot. I think you guys are doing assignment 9 this week. It might be 10. So anyway, hope everything is going well. So let's get on with the lecture today. So why are we talking about FileIO and what is I/O? So first off, I/O stands for input and output, which just means that you are taking information into the program or shoving information out of the program. And when you're doing that to a file, you're going to make it persistent. All right, so normally up until now, every program that you have run pretty much asked the user for some input, they typed something in, it calculated a response, and it printed it back out on the screen because we've been using a lot of console reading and writing, either with system.out.println or with console.writeLine when we're outputting, and the equivalent scanner or readline from the other side to get information in. So the problem with that is that there's no way for the program to persist anything from one run to another. So as soon as the program exits, everything that it knew is lost, which isn't very practical. So a file allows us to read information in from a file, which is better than reading it in from a user in some circumstances, and writing it back out to a file allows us to put our answers in a file. So with this set of mechanisms that we're going to look at today, and with some additional objects, you guys would be able to take input in any format that somebody might give you. So you might say, well, when would this exactly happen? So like, here's a good example. You guys just recently did a test, and we have to get that test out of D2L and put it into Gradescope. And when we do that, when we output it out of D2L, it actually comes out as a Excel spreadsheet. And so then we have to do some munging on it to get it into the right format. But we actually could write some code to read the data that's coming out of that file and then do something with it. So you might have a circumstance where you get some data from somebody, which may have grade information in it, it may have test answers in it, it may have weather information, it may have just a block of, projects that need to be worked on or nodes or whatever it might be. Lots and lots of examples of why you might get a file with data in it. And then you might be expected to write a program that does something to that file. Maybe it reads it in and calculates something. Maybe it outputs another file that's similar to it but has some differences in the formatting, or whatever the case may be. So these are real common examples. So reading from a file and writing to a file are something that you'll actually find yourself doing relatively frequently. In this example tonight, we're also going to take a look at reading and writing from things that are not files, which could include the internet. There's actually a chunk of things that you might need to do where you would go out to some other server, get information from it, maybe munge it and write it to a local file or something along those lines. And I'm going to show you a pretty interesting example of that in a few minutes here. So the first thing to know is that when you're dealing with files, you are basically dealing with the same thing that you were dealing with when you were reading and writing from the console. It's not that tremendously different. The concepts are the same. You read in a line, you do whatever you're doing, and you write out a line. The only thing that's different is that you're doing it to a file rather than doing it to a console. So the next statement that we have here is that you have to be comfortable with try and catch, because, and this was the content from the last lecture, try and catch were a way of looking at exceptions that might happen. Well, when you're dealing with files, a lot of different exceptions can happen. So the first thing is, somebody might tell you to open a file name which is not there. There is no file called a.txt in your local directory. When you try to open it, it's going to throw an exception. So that would not be good. If you don't catch it, the program actually won't compile. It won't let you write something that might have an IO exception without you putting a try catch around it. So it's super important that you do this. If you try to compile it without the try catch, you're actually going to get a compile error saying this method may throw an exception and you didn't catch it. So got to be comfortable with dealing with exceptions. That's definitely important. Okay, so let's talk about streams. These are like little rivers and they have water. No. Okay, so the reason that we call them streams in the programming term is that they are similar to the real world idea of a stream, which is there's some amount of data which is flowing either in or out. And we can have input streams and we can have output streams. You've actually been dealing with this since the very beginning of this class, and actually since 1321. The most common input stream, the most common input stream is your keyboard. And so anytime that you try to read from system.in or from the console, what you were asking the computer to do was to read from a very specific device called a keyboard. And when the user typed stuff on the keyboard and hit enter, it understood that that was a line, and that's when your read line or whatever it was that you were using to pull the data in, or the scanner, that's how it knew to get the next line out of the stream, which the stream, again, was the keyboard. So all we're really going to do here is we're going to substitute the keyboard for a file when we're doing input. Likewise, every time that you did a system.out or a console.write line, what you were actually sending it to is a device called the display. And you have been, up until now, only just expecting that anything that you did went directly to the screen. Well, another stream that you could use would be a file. And so you can actually, instead of writing it to the screen, you would write it to the file. But again, the way that you do that is actually very, very similar. I just need you to understand that the keyboard, the screen, files, and ultimately something called sockets that we're going to talk about later in the lecture are all examples of streams. And they can all be read from, and they can all be written to. You're used to reading, okay, to be clear, some of those examples are only for reading or only for writing. You cannot read from the screen, and you also cannot write to the keyboard. Those are not acceptable things. So we have screens, keyboards, files, and sockets. And all of those are readable or writable depending on their particular deal. Another reason that you might throw an exception, going back to the previous thing, is that some files on your file system you may not have permission to read or write from. Some files may be read-only, which means that you can read from it, but you cannot write to it. So if you attempt to write to it, you would get an exception. Some files you may not have permission to at all. They may be owned by another user on the computer. And so these are things that the operating system takes care of for you. It has permission sets, and it only allows you to do certain things. So again, these are other reasons why you might get exceptions when reading from a stream. And it's also possible that you get exceptions while trying to write to a stream if you don't have write permission, or if the file system is full, like if your hard drive is completely full up and you try to write to it, that's not going to be allowed. Likewise, when you're dealing with sockets, the socket may have closed because the server timed out or something along those lines. And again, we'll get to all that in a minute. Okay, so the important part of this slide is think of input and output as streams. And an example of a stream would be your keyboard. That is a input stream. An example of an output stream would be your display, your screen. Okay, so the general process that you're going to work with a file is that you're going to open it, which is something you've never had to do with the keyboard or the display. They are inherently open for you when you run your program. So that's the good news. But if it's anything other than the keyboard or the screen, the first step that you have to do is to ask to open the file so that you can then read from it or write to it or whatever it is that you're trying to do. There are other words here, append and create, which are also important. It may be that you don't want to override everything that's already in the file. You may just want to append some additional information to the bottom of a file, whereas create has the effect of destroying anything that was there and completely making a new file. So that's what those words mean. So once you've got the file open, either for reading or writing, you then would do your reading and writing statements, which are probably something equivalent to console.writeLine or system.out.writeLine, println. And then eventually at the end, you're going to close the file stream. Now, what does it mean to close? It just means that you're done with that file. And it's very important that you call the close operator. If you don't call it when the program ends, it will automatically close the file for you, but there are conditions where you can have too many files open. Actually, your file system has limitations on how many files any given program can have open. So it's very important that when you're done with a particular file, you go ahead and close it out so that it's not in use. Also, your file system prevents more than one person from trying to write to the same file at the same moment. And that's to try and save you some headaches, because if two different people are attempting to write into the same file, then in reality they're just clobbering each other. So it tries to stop you from doing that. So effectively, while you have a file open, somebody else would not be able to open it, which means that they're going to have to wait until you are done with your program. So the sooner you can free it back up for them, the better. All right, and then I want you to imagine an active cursor. All right, so you're used to the idea, probably at this point, that a cursor is where you are in a program. So like if I were to open up Microsoft Word right now, there's a flashing line at the beginning of the program, and that is where I will type. So as I start mashing keys on the keyboard, the cursor will move across the screen, showing me where the next place is to input. And you're also used to the idea that, of course, you can move the cursor with your mouse to another place, click there, and then start typing there. So I want you to picture when you're doing reading and writing from a file that there is a cursor going on inside the file that's moving around as you read or as you write. It's an important visualization because it'll help you see what's actually going on. All right, so if you're going to read in a file, you need to understand what format the file is in that you're getting data from. And of course, there are many, many different formats that files can be written in. So the simplest answer is that you might just have one element per line. What's an element here? So like, let's imagine that I'm reading in a bunch of students' grades. One element might be a student ID and the grade. There might be multiple elements per line. So I might be reading in one line that has every test grade that you have, or every quiz grade, or maybe every test and every quiz grade. And that would mean that that line has many different things in it that I want. So you have to understand, when you're reading data in, what format did they give it to you? Today, it's common that you would read in maybe 4 or 5 different formats, we might say. So a comma-separated file is a very common format. So if we go back to my example of my students, I have a student ID, let's say, and then I might have their test 1 grade. So I would have student ID, comma, test 1 grade, student ID, comma, test 1 grade on the next line, and so on and so forth. So every student is one line by themselves, and after the comma, I have their first test grade. There may be more than one comma in there. So for example, I might have student ID, test 1 grade, student ID, comma, test 1 grade, comma, test 2 grade, comma, test 3 grade, comma, final exam grade, or something along those lines. So that's a comma-separated file, and that's usually abbreviated as a CSV. So you frequently see CSV files that get passed around. That's a very easy way to read in information. There are, of course, issues with reading comma-separated files. For example, what happens if a student ID could have a comma in it? Then you're going to have to deal with that situation. Another idea is to do a space-separated file. So instead of using a comma, you would use a space or perhaps a tab. Tab would be the more common one. And so a tab-separated file would be a TSV, tab-separated value. And that's a relatively common one. There are other examples of formats that files might be written in if you're transferring data back and forth. Probably a very common one that's used today is something called JSON, J-S-O-N, and that's not something that we're going to deal with a whole lot in this lecture, but you are going to see it later on in the lecture. It's just a way of putting data in a very specific format so that it's easy to parse, which is the word that you would use when you're pulling information in from a file and having to go through and parse it. And then the final one that I'll mention is an XML file. And that looks very much like an HTML file. So if you've ever written some HTML, you're used to having the little angle brackets around the particular keywords, like bold would be an angle bracket, B angle bracket. So XML allows you to define the tag names inside of there and then have values. And those are all just ways of formatting the data so that it can be read in. So it's important that you understand what format you're getting the data in before you start writing your program, because that will determine exactly what you need to do after you read it in. The last option is that the file might be in a binary format. Now, what does that mean? So everything that I've talked about so far means that it's plain text. And if you're on a Microsoft Windows machine, you have something called Notepad that's installed. Notepad is purely a text editor. It is not a word processor, it's just a text editor. So anything that I've described so far, JSON, XML, comma separated, tab separated, all of those would open up in Notepad and you would be able to see the text directly line by line yourself. However, if you attempt to open up a binary file in Notepad, it's just going to look like a bunch of garbage. It's really not garbage, it's just that Notepad has no idea how to display it because the data inside there is not in text format, it's in some binary format. So what does that actually mean? Well, everything that you've stored in a data structure so far, and like a string would be one example of a data structure, there's some additional stuff that has to be recorded about a string, like how long it is, and what the end character is as to how it's being stored in its little data structure. And when we get to some of the other data structures that we're going to look at later on in the module towards the end of the class, you'll see that there's a bunch of other data structures where the data is stored in a particular way. An array would be a good example. We've talked about array lists, and we've talked about a couple of other minor things like that. But those would all be internal structures that were used in memory to store data. It is possible to write some of those structures directly into a file. And as a result, what you get is not plain text, because of course you could be storing numbers, or you could be storing some combination of numbers or other stuff in there. And so the format of that file would end up being binary. If you were to write something in a Microsoft Word document and open that Word document in in Notepad, you'd be quite surprised to find that what's in there is not in any way the words that you wrote. And part of that is because there's a lot of additional information that it has to store as a word processor. It needs to understand what color, what font, how big was the font, is it bold, is it italicized, is it underlined, is it struck through, is it postscript or prescript, is it tab indented or space indented, how far from the margin is it, how big is the page, how all of that information has to be stored inside of your Word document. So the Word document doesn't just store words, which is ironic because that's what you would think it is. It actually stores it all in a binary structure that is very specific to Microsoft Word. And so if you were to try opening a Microsoft Word document in Java and read information in from it, you'd be surprised that you would find a lot of what would effectively look like garbage. So again, you have to know what format it is that you're reading in. All right, so how do we actually go about doing this? Well, as I mentioned, the first thing that you would typically do is you would open up the file. Once you have the file open, you're typically going to layer different streams on top of the file depending on what it is that you're trying to do. So opening the file by itself really doesn't do anything useful for you. It's a raw file at that point, and there's no particularly simple way to just directly read information out of that file. So what you're actually going to do is you're going to put a stream on top of it that allows you to pull in information character by character. And actually, you can put a stream on top of character by character that would allow you to read in an entire line at a time. And that is probably going to be what you would want more often than not. Sometimes you'll need to read it in character by character or even byte by byte if it's binary. But more often than not, if you're dealing with some kind of text, you're probably going to want to have a higher level stream that understands the structure of a line of text as opposed to reading it in byte by byte. So it's not uncommon to have layers of different streams on top of each other that each know progressively how to deal with something bigger. At the very end of that, you might have something that understands how to read a JSON file or an XML file that we talked about, or even perhaps a Microsoft Word file, because it may have a built-in method for dealing with Word files inside of Java. Okay, so let's take a look at some code here. So this is going to be an example of layering in Java. So we started off here and we get a new input stream. This is basically opening the file. All right, so we're assuming that the file name that we're dealing with here is source.csv. And what we are saying is file input stream, we're getting a new file input stream. We're passing it the name of the file, which is source.csv, and we're storing that in a variable which we're calling FIS, which is of type file input stream. All right, to be clear, this is just a variable name. I could call it Bob and it would work just the same. Obviously, because this is an example where you're looking at new stuff, we tried to name it something that was close to what it is that you're dealing with, and this is a file input stream, which is why we got FIS. Okay, so this by itself opens the file source.csv, and CSV would be comma separated. But this is very, very low level. If I were to try and read from this file, it would actually simply be reading it in byte by byte, which is probably not very useful. So this is why we're going to layer something on top of that. So the first thing that we're going to layer on it is what's called input stream reader. So again, we're going to create a new input stream reader, and we're going to pass it the open file that we made in the previous line. So we're taking this FIS and we're passing that as a parameter into input stream reader. And that produces for us an input stream reader, which we're calling ISR. That has the ability to read character by character from the file, which is a step up from where we were reading bit by bit. And now we might want to layer on top of that again so that we can read an entire string. And so this one is called buffered reader, and we would take in a new buffered reader. And again, that one actually takes the previous one as its parameter and gives you a BR. Once you have a BR, you can actually just read from it, at which point you'd be able to read. There is a shortcut to this, which I'm going to show you in just a second, but I do want you to understand that it is common that the raw file that you have decided to open, you would never actually interact with that particular variable. You would layer something on top of that that allows you to then interact with it in a more useful way. The second thing to notice about this is all of this was wrapped in a try-catch. So if you remember from the last class, this try is here because any of these objects or any of these methods may throw an exception. And very specifically, if I were to not put this here, this would not compile. It would tell me that file input stream can throw IO exceptions and I am not attempting to catch them. So I must catch IO exceptions when I'm dealing with each of these. So the try catch here gives me an IO exception as a type. And again, this could just be exception if you wanted to be more generic, but IO exception is particularly what you're going to be dealing with when you're dealing with input output. And this is just simply printing out an error message. So if something goes wrong, for whatever reason, it cannot open the file, then this will happen. Now you might be sitting there going, but you wrote the code, you obviously know the file is going to be there. Why on earth would it not be able to write the file or read from the file? And again, there are many, many ways that that could happen. You could write an application for your phone, and you could put that in the Play Store. And when the application is first opened on somebody's phone after they have installed it, you could write a file out that has some information in there, like a license key or the user's name or some other information that you're keeping track of. Let's think you're writing a game. You might want to keep the high scores locally on the phone. So you might write a file called high scores. And then the second time the app is opened, it would read in high scores and remember all of the information that was in that file. And you might think you're very, very clever. And why on earth would you ever need to do any kind of exception handling around opening your highscores.csv? Well, the answer is because it turns out you're not the only person who can read and write from that file. If the person's phone were to fill up, or if the person opened up their Files app and browsed into the directory where your actual file is stored for the app, they could just delete it. They could also reinstall the phone, at which point, without the particular file being there, you have to deal with the fact that it's not there. And so in that circumstance, normally what you would do, if you were dealing with like a high score, is after you try this, after you try to open it, if it's not there, in the catch, you might just go ahead and create it, because the assumption is you're starting over, or this is the first time it's been installed, or whatever else. So again, very important that you deal with exception handling when you are dealing with files, because the world around you will constantly change. Users will go in and delete files, they'll add files, they'll do all kinds of terrible things to you. They'll make the file system completely full, which has nothing to do with you, but all of a sudden you aren't able to write to the file that you should have been able to write to. So that's why you have to keep doing exception handling. Okay, so here's an example of structured information that might be in a file. So we might have an airline, and that airline might need to keep track of all of their flights. So for example, you might have a flight number, which might be AA123, apparently American Airlines. The origin airport might be BWI, which, if I'm not mistaken, is Baltimore, Washington. The destination airport might be San Francisco. The number of passengers might be 235, that's a big plane, and the average ticket price was $239.50. That seems low. All right, but anyway, so from Baltimore to San Francisco, this is one line of data. And so the example here is that we may have a file where we have a bunch of these lines of data. Here's another flight down here, and so on and so forth. And as time goes on, more of these are added in, and we now have the ability to calculate what is the average price of flights from San Francisco to Baltimore, or vice versa, or how many flights left today might be a question that you might want to ask. Maybe it's a different file every day that lists all the different ones. So this is a comma-separated file. All right, so we're going to do this airline example, and we're going to do it in both Java, and then we're going to do it in C#. So what I'm trying to do here is I'm trying to read in that file, and I'm going to print out some of the data that's in there. All right, so we start off, and you're going to need a couple of imports up at the top. Very specifically, you're going to need java.io. There's a bunch of different ones inside of java.io. It's fine to just import java.io.star, and that'll give you all that. You may also need Java utilities, so we'll go ahead and add that in. All right, so we have our main method. Everything is hunky-dory so far. We're going to have a try and a catch because we're going to deal with file stuff. So that all looks good. We initialize a string to empty, and we are going to open up a file. I did mention that there was a shortcut in Java for opening up the file and not having to have 3 layers of things on there, and that's using scanner, which you had also used for reading input from the user on the console. So we start off and we create the file. So a file name, which is not anything to do with the actual file name on there. This is just a variable that we are going to keep track of inside of our code. We're calling it myFile. Gets new file and then the file name. This is the actual file name on the file system. So that's what it's actually called if you were to open up Windows Explorer or the Mac equivalent, which is File Explorer or something like that, I think. So this gives you a variable called myFile, which has an association to a physical file on the file system. The next line you will be familiar with, which is scanner. We're going to call the variable scan, gets new scanner, but this time instead of passing it system.io, what we're instead going to pass it is myFile. So when you did system.io, what you were doing was you were saying, I want you to read from the keyboard. And that was the typical thing that you've done up until now. But this time we're doing myFile, which means I want you to read from that file that is associated with this variable. You cannot just put a file name in here. It does not know how to do that. What Scanner expects to take in its constructor is an object of type file. And the only thing that you really have to do to make that is create new file with the file name. So at the moment that this happens, you now have a variable called scan, which is associated with the file. And what I want you to picture in your head is that that magic little cursor is set to the very top left corner of the file. So the first thing that we're going to do is we're going to do a while loop. We're going to say while scan, which is that variable that we just made up here, has next line. That's not something you ever really had to deal with on the keyboard. Then we're going to do scan.nextLine and assign it to a string. So this is a string that we initialized up here to a blank string. So this reads in the first line out of the file and puts it into a string called dataLine. So now what I want you to picture happening is that that little cursor moved across the first line and carriage returned onto the next line, and it is now sitting at the beginning of the next line. When you come back up to the beginning of this while loop, it checks to see, is there another line? And assuming that there is, it'll allow it to read the next one and go on to the next line, and so on and so forth. Eventually, the cursor is going to get to the end of the file, and at that point, scan.hasNextLine is going to fail, at which point you're going to come out of this loop. If you didn't have the loop, you would only read one line out of the file. Almost every time that you're reading from a file, you're probably going to need a loop because you're going to read in many lines out of the file. So this is a very common block of code. You open a file, you create a scanner, which is based on that file. You say, while the scanner has a next line, scan.nextLine. And that will give you a string, which is the first line out of the file, and then the second line out of the file, and then the third line out of the file. What you do with that data is up to you. So in this example, we're using the split function on a string, because dateline was a string, you'll remember. Data line, not dateline. I think dateline was a TV show. Data line dot split, and split takes in a parameter, which is the variable that you wanted to split on, which is a string. So you specify a string that you wanted to split on, which in this case is a comma. So that's going to break up that line. And if we go back and we take a look at what the line looks like, that's going to break up this line into 1, 2, 3, 4, 5 different variables. And what it actually does with those variables is it's going to put them into an array of strings. So tokens at position 0 is going to have this. Tokens at position 1 is going to have this, and so on. Sorry about that. I decided to choke on air, apparently. All right, so tokens at position 0 would have, oh, come along, you can load, you know you can. All right, tokens at position 0 would have AA123, whereas tokens at position 1 would have BWI, and tokens at position 2 would have SFO, and so on and so forth. So this gives you a bunch of cells in an array, each of which has a string, and then of course you could manipulate them however you want to. And in this case, all we did was we printed it out, so it's not a very useful program. It just prints out the original line, even after it's split it up into those separate tokens. So this block of code is a very common block of code that you will end up writing many times, where you read in a file, you pull each line in one at a time, you do something to that line, and then you read in the next line and do something to that. A common thing that you will end up doing is using something like split to break up the line into its various parts, and then you would process each bit however you're going to do it. I'm going to show you an example again in a minute. All right, so the equivalent code in C#. In this case, you're going to make sure you use system.io, using system.io, and then you still have your try and your catch. All of that is still the same, but this time the way that you open the file and read it is a single statement. So you're going to use an object called streamReader, which takes in a file name. So you're going to say new streamReader source.csv, and you're going to give that a name, which in this case we called it SR. You can of course call it whatever you want. And then very similar to what we were talking about in Java, you're going to say while not SR end of stream. Okay, so end of stream is a common thing that you're going to hear. EOS, EOF. Those are words that you're going to see. EOF stands for end of file. EOS stands for end of stream. In C#, it's literally written out as end of stream, as you see there. But you should be aware that in different languages, these are called different things. It's the end of the file, the end of the stream, whatever you might need. So while not SR, which was our variable that we created up here for our stream reader, while not SR.endOfStream, which means we are not at the end of the stream here, we're going to do SR.readLine, which is very similarly going to pull in one line for us and assign it to data line, which we then use the same split function, it's capitalized in this case, to break that up into a bunch of array of strings. So again, tokens at position 0 has the airline number AA123, and tokens at position 1 has the source airport, and tokens at position 2 has the destination airport. All right, and your exception handling is very similar down here. IO exception is what you're catching, and you're just doing a console.writeLine. So hopefully this makes sense. All right, so how about writing text to files? Pretty much works the same way as writing to the screen. The only difference is that you're going to first open the file, and then you're going to use PrintWriter or StreamWriter, depending on which language you're in, to actually put each line in there. And you do it line by line, just like you do on the screen. So you could have a while loop that prints out all the different lines. All right, so here's an example of writing a file. And again, we're in Java. You're going to import java.io, and we start off, and we have a file called myFile, and that gets a new file on output.txt. And then we have a print writer, which we're calling PW, and that gets a new print writer on myFile, which is what we just made right here. And then we just print to it. So printwriter.println, printwriter.println, and at the very end, printWriter.close to close the file. Okay, we didn't actually close the file in the other example, and you should remember to do that. There's actually a comment down here that says you should have done that. We didn't do it, but you should do it. You simply call close, which is either lowercase c or a capital C, depending on which language you're in, on the object where you opened the file. All right. And I said that wrong. I said it was on the object that you opened the file. It's actually on the printWriter object is what you close here, not the my file. All right, sorry about that. All right, over in C#, pretty much the same thing, except instead of printWriter, it's StreamWriter. And so we open up a new StreamWriter on the file, StreamWriter.WriteLine, StreamWriter.WriteLine, and we have the catching of the exceptions and StreamWriter.close, the same thing. So, I mean, honestly, that code is identical, except you're changing the word StreamWriter to the word printWriter. But other than that, I believe it's identical. And okay, printLine and WriteLine. So maybe not exact, but there you go. And again, you have to remember to using system IO, otherwise this will not work. All right, if you were dealing with a binary file, which could be an audio file, it could be an image, it could be a PDF, it could be a Word document, an Excel document, or it could just be some random binary file that's in some random binary format, then you're going to have to use the lower level ones. You can't print line or write line with binary data. So you would use binary writer and binary reader in C#. All right, so here is the example of that. And in this case, when we open the file, we're using file stream as the object method. Again, it takes one parameter, which is the name of the file, and then you have to specify what mode you're trying to open the file in, which is either going to be read or read write. In this case, we're opening it as a create. So it's going to create the file as a writable file. And then binary writer gets new binary writer on that file. And now we have a byte array, which we are just opening up an array of bytes, and we're going to put some random stuff in there just so that we have something to do. And then we're going to write that. So that happens with binary writer.write. We pass it the array, and we tell it where we want to start and where we want to end. We want to end at cell 1000. All right, and if there's a problem with any of that, we catch the exception. So that's writing a binary file. Honestly, writing a binary file is the least common of those. You'll more often be dealing with text. Okay, so general software engineering tip, anytime that you open a file, you need to get in the habit of closing it, and you should close it as soon as you are done with it. So the moment that you're done writing to the file is when you should close it. You will learn this lesson the hard way. If your program crashes at any point during writing a file, it's possible that what you get is nothing, even though you may think you have written a bunch of stuff to the file. Why? Because everything that happens with a file happens with a buffer. And I'm going to explain that in a little bit more detail in a moment. But trust me when I tell you this, when you are done dealing with a file, the very first thing you should do is close the file, which will have the effect of flushing the buffer and getting everything into the file and then closing the file on the file system. So you may have hundreds of files that you're dealing with. It's not uncommon that you might need to read in 1,000 files off the file system and write another 1,000 files in response, or read in one file and write 1,000 files out. Think of reading in every student's grade from test 1, and then another file for test 2, and another file for test 3, and another file for the final. Yes, I know there's only 2 tests in the final in this class. That might be 4 files that you read in, but then you might want to write out a separate file for every user that has their grade in it. So in that case, you would end up writing out, for this class alone, 130 output files. So again, as soon as you're done with each file, close it. Very important. Don't know what else to say about that. So good practice, get in the habit. If you do not close it at the end of your program, assuming your program did not crash, it will close it for you gracefully. But again, that's a big assumption that your program didn't crash. The other thing I will say here is that I've mentioned that there is standard input, which is your keyboard, and standard output, which is your screen. There's also another magical thing called error device, which is also your screen, but that's where errors go to, and none of those should ever be closed. You can call close on them, don't do it. Okay, so let's talk about buffers. And I'm going to recall a story for you when I was in college. This was back in the year 1772, I believe, and I was learning to program in C. And I wrote a program, and it was not doing what it was supposed to do. And so I started adding in debug statements. I was very new to programming C at this point. I started adding in debug statements, so I'm doing some prints in there, and I'm basically trying to see, is it working? Like I have a loop, and every time it goes through the loop, it's supposed to print something out for me. And it wasn't working, and I wasn't even getting the print statements. So I spent all night, and I literally mean all night, before an assignment was due, trying to figure out why my loop wasn't working. And at about 6 o'clock in the morning, I passed out. And when I woke up at about 8 o'clock in a panic, because of course this was due at 8:30, I suddenly realized what the problem was. And the problem was that the print statement, I suddenly realized what actually happened was I think I called somebody and they told me, you're an idiot. The print statements are being buffered and they're not being printed out. And I said, what the heck is a buffer? And they said, just trust me and do this. And then magically it started working. Okay, so cool story. Why am I telling you all this? Because buffers will eventually drive you crazy. When you print to the screen doing a system.out.println line or a console.write line, you are used to the fact that it happens instantly. The moment that that line of code appears in your code and executes, boom, it appears on the screen. And that's because the screen is flushed very often. Every time you do a print line, it actually will flush the screen for you. It does not do that to the file. It will flush whenever it feels like flushing. What are we talking about here? So when you write to a file, what's actually happening is you're writing to a file buffer. And every now and again, Java or C# will decide now is the appropriate moment to actually write that out onto the file. Why? Because it's very inefficient for the program to actually interact with the disk constantly as you're telling it to write. It turns out that that's really, really slow. So to speed things up, rather than doing it in real time, what it does is it writes it into a buffer. And then when the program is not very busy and the operating system is not very busy and the hard drive is not very busy, at that moment it will attempt to flush it out to the actual hard drive and write it. This is why I said you could write code where you do an open on a file and a bunch of prints to the file, whether they be the Java or C# version, but you do a bunch of prints, and then your program could crash after all those prints have happened, and you could go look at the resulting file and find that there's nothing in it. If that happens, then you are in a situation where all of that data was written into the buffer at the moment that you did the print, but the buffer never actually flushed out there. So every time you write code where you're printing something out, one of the things that you need to do is you need to call flush, which in none of these examples did we actually do. We're going to do it in the next example that we look at, just to make sure that you understand that. All right? So make sure you get used to calling flush, and it just gets called on the same thing that you call close on. All right? So let's move in a different direction. I'm going to pop open two little Replit windows, and I'm going to show you a little bit of code that I wrote earlier. So in Replit, it is possible to make files that are not actual source code. You can actually just have files. So you can see this Replit URL. If you want to pause, you can write it down and you can come play with this the same as all the other Replits that you've seen in here. There's a Java version of it, and if I tab over, there is a C# version of it as well. Okay, so in both of these cases, I have added a file to the Replit by clicking Add File up here, and I simply named the file .txt. In this case, I would totally have said that there were numbers in there, so I'm going to reload that file because I think it's in a screwy state and it's not showing me what's going on. But anyway, this is just made up data. I obviously just completely typed in random numbers, which are supposedly student IDs, and grades, which are the grades from some test. Who knows? And so what I'm doing next is I'm going to make sure that that's also here in the C#. It is, there it is, and they are the same. I'm just all tabbing between the two windows. One of them is Java, one of them is C#. In each case, I'm going to write a main function, which is going to take this data and it's going to tell me what the average of the scores are. So what it's going to have to do is it's going to start off with the cursor right where I have it blinking line up there on the top left, and it's going to read in one line of text using the read statement, whatever the read one is for your language. Then the cursor is going to move on to the next one. Once I have read in that line, I obviously have to do some work to break it up into two things. One thing is the student ID and the other thing is the actual grade. So I'm going to use that same split method that we saw in the previous example. And I'm going to store that number in a sum variable where I'm just going to add up all of the sums of all of these. I'm going to generate a sum of all of the numbers that are in here, and I'm going to count how many numbers I have. That's how you calculate an average. So it'll take the 100 out of here, it will add it to my running total, and it will increment my count so that I know that there's 1. Then it's going to add 92 to the running total. Then it's going to add 70 to the running total. This poor person got a 0, so it's going to add a 0 to the running total and a 50 to the running total. And then at the end, it is going to divide the sum of all those numbers by 5, because there are 5 numbers in there. Okay, so that's what's going to happen. Let's take a look at the actual source code. All right, so let's do Java first for no apparent reason. So I have a public static void average grade, which takes in a file name, which is a string. I'm expecting that you will give me a string here. All right, and so I start off and I initialize my grade sum and my grade count. This is the variable that's going to hold the sum of all the numbers, and this is how many numbers I have read in from the file. So this should work whether there's 5 numbers in the file or 1,000 numbers in the file. All right, and so we start off and we open the file. So we're going to say grade file gets new file, and then we're going to pass it the file name, which came in as a parameter to this method. And then I'm going to use the scanner. So I'm going to call scanner.readFile gets new scanner on that grade file. Cool. And now I'm able to do has next line in a while loop. So I'm saying while the read file has another line, then I'm going to next line the read file, which pulls in a line and gives it to me in a variable which I'm calling student. So remember that has the student ID, comma, their grade. Then I use the handy dandy little split function, which is going to break that line up into 2 different string or into an array of strings, where the first cell is going to get the student ID and the second cell is going to get the grade. And then at that point, I call, just to make it easier for myself, I call the first one the student number. That's just pulling out mapping, which was the array name from up here. I pull out cell 0 and I store that as student num. And then I have to convert the other one because it's currently a string and I need it to become an integer. So I use integer.parseInt on mapping 1, which again was a string, and that gives me a grade. Down at the bottom, grade sum plus equals grade count plus plus. I do print out the student and the grade just so I see it. And then I'm doing the very important readFile.close in order to close the file. I do have my catch just in case something goes wrong. And then at the end, I calculate the average by taking the sum and dividing it by the count, and I print it out. So hopefully all of that makes sense. I'm going to go ahead and run that. And I actually think if I move my window here, it is being screwy for some reason. So I'm going to refresh that, and I'm going to go over to the other window in C# and talk through that while that's refreshing. I think this one is in better shape. It is. Okay, so this is the C# version of that same code. Nothing here is really different. Again, I'm just using lowercase string for strings, and I'm using stream reader, which does both of the lines that I had to do in Java, where I opened the file and then used scanner. So stream reader does both of those things for me. So stream reader, while grade file, which is that stream reader, is not at end of stream, then I do a read line, and then after that all the same. So this is the split to break it up into the 2 parts, and I get an array of strings called mappings. I rename, or I name student num, whatever is in cell 0. I print out what's happening. I calculate, I convert the other string into an integer. I add it into the sum and the count, and I close the file. And then down at the bottom, I calculate the average, and I do the print line effectively to tell me the grade. So down at the very bottom, we'll come back to the rest of the code that's in here, but down at the very bottom, you can see I call average grade and I pass it a file name, which is test1 grades, which is out here in that list. So when I run that, what you're going to see is, with any bit of luck, there are the lines from that file. And I'm just going to open up the file so that you can look at the file. So this is the raw file that it read in, and you can see when it read in the first line, that's the student ID, 12112, and that's the grade, which is 100. All right, and then it ran through all of these. It got the 100, the 92, the 70, the 0, and the 50. And just to prove a point, if you take those grades and you add them together, you would get something like 100 plus 92 plus 70 plus 50. We don't have to add in the 0 because obviously they got a 0. And I'm going to divide that by 5. You see that the average is 62.4, and it printed out average is 62. And that's because I didn't bother to deal with the fact that it's a float when I was reading in the numbers and dividing them. I set them up as integers, so it did integer division. If I changed them to floats, it would have been fine. All right, so that calculates the average correctly. I'm going to run back over to the Java window, which is still loading for some strange reason. And I'm just going to hit run there so that you can see it. It has the same call at the bottom, test1.grades, and life should be good. And I will get out the exact same output because, of course, it's running pretty much the same code. Cool. While Java's being Java, I'm going to come back over to C#. And just to prove a point, I'm going to name the file test2grades, which I do not have. And I'm going to try running it. And you're going to notice that I'm going to get my catch exception is going to happen. And my exception says unable to open test2grades system IO file not found. So if we scroll back up here, we can see unable to open info about, oh, that's not the right line, sorry. Unable to open, and then I gave you the file name. So that's where that is coming from. That is my catch that's happening there. The rest of it is because I actually printed out the raw object, which is the +e. You'll notice I didn't stop the method. At that point, it actually went on and tried to calculate this, which of course is an error. So that throws another exception because I'm going to get a divide by 0 because at that point, grade count is 0. So that was bad programming. All right. So that's all that. And just to prove the point that Java did actually eventually work, there it is. And it calculated the same average, which was 62. All right. So that is everything that you need to know about reading and writing from files. Hopefully that's pretty easy. The next thing we're going to do is we're going to talk about another thing that you can do with all of this, which is reading and writing from the internet. Ooh, say it with me. Ooh. All right, what do I mean by reading from the internet? Well, it turns out there's lots of stuff on the internet that's really, really handy and useful. So there's probably sites that you go to on a daily basis. You might go to Reddit or Rate My Professor and talk about how wonderful I am and all of those great things. But you might want to write that in code where you would want to be able to pull information in. So for example, you could conceivably write a program which interacts with D2L for you or interacts with LExpress for you. Now, this would be a little bit more advanced than what we're going to cover today because you'd have to know a lot about the internals of how D2L works and how to authenticate to it and all of that good stuff. But it is plausible. So the example we're going to do today is there are a bunch of services on the internet that will give you just cool information, is what I'm going to say. And I'm going to show you an example of one of those. So how does this work? Well, in this example, we're just going to pull in the Google homepage, which isn't really very useful, but well, here we are. So a couple of things that you need if you're going to do this. So we've already talked about Java IO, but if you're going to be dealing with the internet, then you also need java.net because you're actually doing connections. And in this case, when you're opening a file, the file that you're opening is what's called a socket. Sockets just mean that you are dealing with the network on the computer. And sockets inherently know how to connect to remote servers. They can also be local servers. It is possible that you could talk to yourself, which sounds very screwy, but it actually happens more often than you would think. But in this example, we're talking to a server out on the internet. The server that we're going to talk to is www.google.com. The port on which we are going to connect is port 80, which is the standard port for HTTP, which is what you use every time when you open up Chrome, Safari, Firefox, or Edge, or whatever other browser you might be using. So when you type into your browser www.google.com or just google.com, it works either way. What you're actually doing is you're making a connection to something called port 80 on a server called google.com. If you type in HTTPS, google.com, you're actually connecting on port 443. So anything that's encrypted, the port number changes from 80 to 443. If you're interested in all of this, take a networking class. They'll teach you all about it. But for the purposes of today's lecture, what we're mentioning here is that this is the name of a server that you want to talk to, and this is the port. If you're dealing with HTTP traffic, this will always be port 80. If you're dealing with 443, things are screwy because you have to speak encryption, and that's not going to be as easy as you think it is. So for all these examples, you're going to be wanting to deal with port 80. All right, so instead of opening a file, what this does is it opens a socket, which works just like a file. Instead of it being a local file in the file system, it's a socket to this remote server. Once I have that, I'm going to create something called an output stream, and I may also want an input stream. All right, so yes, there we go. I was like, where's the other one? Print writer PW gets new print writer. This is going on OS, which is the output stream. Okay, so an output stream from the perspective of this computer is me sending data to google.com. An input stream from the sense of this computer is google.com sending information back to me. It's input to me and output to me. So when you're thinking of inputs and outputs, you need to think of from the perspective of the computer that you're writing the code on. All right, so we opened an output stream because I wish to speak to google.com. It's important that I be able to do that for what we're doing. And I create my print writer, which allows me to write to that socket. Now I'm going to do a print on that socket. So I'm saying pw.println, and what I'm typing is this very, very strange thing where I wrote get space / index.html followed by 2 carriage returns. Those carriage returns are critical, as it turns out. Okay, pausing from the lecture for just a moment, let me explain what's going on here. This is the HTTP protocol. This is how you request a page from a remote server. The details of all that are not particularly interesting, but you will always do get, which is the word that you use when you're trying to access something on a server, and then you will pass it the thing you're trying to access, which is the name of the page. If you had put in an image file here, so if you had asked for, google.jpg or something, then it would return the JPEG from the server instead of returning the index.html. If you've ever written some HTML, probably in CSE 1300 or in another class if you're doing anything like that, then this is how your web browser actually does it. So this code that we just looked at is the very basics of how Chrome, Firefox, Edge, Safari, they all do this exact thing in the background. They open a socket to the server that you type in the URL bar on port 80, and then they print something along this line of get space / the file name space carriage return. And when they do that and make sure that they flush, which we have highlighted in yellow here to remind you, because if you don't do that flush, it doesn't actually send it to the server. What it will do is it will return to you the actual page from the server. So I'm going to demonstrate this not in code. I'm going to open up a how am I going to do that? There we go. I'm going to open up, don't worry about the details of what I'm doing right now. I'm just making a connection to a server so that I have the ability to actually type in the command. So I'm going to type in a weird command. Don't worry about the word telnet, it doesn't matter. And I'm going to go to google.com on port 80. And this is me actually talking to the server. I'm going to type in get space / index.html, and then I'm going to hit enter twice. And you can see that returned to me a whole bunch of stuff. And you might be saying to yourself, I'm sorry, what did it return? So this was the command that I typed. And you can see what it actually responded with was HTTP 1.0 200 OK. And then it told me the date according to the server. And then it gave me a bunch of information about the information that I'm getting. It set a cookie to tell me who they are. And at that point, I then got the actual text of the page. If I were a web browser and I were able to parse all of this and display it to you, what that would look like is the Google homepage. Now, you might be looking at that saying, that's an awful lot of stuff for just a Google homepage. And the answer is because they run a bunch of JavaScript in the background, and that's what you're actually looking at is all the JavaScript that tracks everything about what you're doing. But you can do this on any web server. So for example, I can do Microsoft.com on port 80. And I'm going to do the same thing there. I got an internal server error because it's set up differently. Some servers are set up where they require you to send additional information beyond this. Let's try. Yeah, okay. Let's pick another site. Think of a site name. Where are we? We're on, Kennesaw. port 80. All right, and that one said it has been permanently moved, and it tried to redirect me to HTTPS and then its own server. So when you go to, in a browser, Kennesaw.edu, you actually immediately get redirected to a secure version. So where it actually connected me to was HTTPS, and I know that because of that little padlock. Okay, well, all this is fascinating, I'm sure. But back in our code, if I can find the window, there it is. Back in our code, what I was doing here was I was making a connection to google.com, and I was sending this weird string get space / index HTML and then hitting enter twice. When I do that, it is then going to return to me a big blob of text. And very specifically, that big blob of text, I now have to read in. So I set up a scanner using the scanner object, so new scanner, and what I'm passing it is my sock, which is the socket that I created up here, get input stream, and that's much like when I made the output stream. Remember, input is coming back from the server, and then I said, while that scanner has a next line, I want you to read the next line, put it in a string called data line, and then I'm going to print out that data line, which would actually show me the values from the server. All right, the equivalent code is here in C#, and the only thing that's really different here is instead of using a socket, as it's called, we actually call it TCP client, and that's because in C# they differentiate between a TCP server and a UDP server, whereas in Java they are considered both sockets. So there's a TCP client, we pass in the host name, port 80, and then we use client.getStream on a variable called ns, and then we create a new stream reader and a new stream writer on that, which I'm calling SR and SW, so that's the read and that's the write. And so on the write, I'm able to do a write line, pass in that same crazy get / index HTML, make sure you call flush. If you don't call flush, it won't work. And then while not end of stream on the reader, read in a line and print it out to the screen, and make sure you close the socket at the end. So same exact code. All right, so let me show you another example of that, which is maybe more interesting. So I went out and I looked up a list of different freely available APIs that are on there. So you can again see the URL that's up here. Almost all of these will work to some extent, but there are some caveats. So these are just services that are available on the internet that you can call, and you'll find all kinds of neat information from them. So for example, this 7 timer one up at the top, I actually fooled with it for a while and I could not get it to work. Their server seems to require you to pass something that's not clear to me. So don't go down that path too far, but this theoretically gives you the weather forecast. And I was able to do it manually, like if you press this, you get the data, but they obviously require that you pass something, and I don't know what it is, so this won't actually work in the code. But halfway down this list, the one that caught my eye was Music Brains. And one of the reasons that Music Brains caught my eye is because it doesn't require HTTPS, which again, I can't do that in Java. All of these that say HTTPS, you can't do it because you have to speak encrypted to the server, and you can't do that just directly by typing. You actually have to go through layers of encryption. You can connect to HTTPS servers in Java, but it's a whole different set of objects, and you can also do it in C#. You don't do it directly like we're doing it here in this example. But Music Brains does allow you to do it directly. So what is Music Brains? Well, if you go to their website, they have a database that has information about pretty much every song, artist, album, and genre that's out there, and it will give you all kinds of information about that artist, that album, that song, and so on and so forth. So the cool thing is that this is available, and this is what's called an API. So APIs are just ways on the internet that you can interact with a service. So think of it this way. Somebody at Music Brains wrote a bunch of Java code, and they allow you to ask specific questions off of them, and they give you back answers. And when I say they, I mean a server that's sitting out on the internet. So when I talk to Music Brains, I can ask it a question, and it will give me back an answer. And the way that I do that is through what's called an API. A RESTful API means that I can do this over HTTP connections, and that's exactly what they have set up for us here. So I'm going to do this. I'm going to make calls to Music Brains from a piece of Java, and I'm going to pull back some neat information. So just going to show you the code first before we get started. So it's in this same exact replit, and it's here for both Java and C#. So let me just scroll up and show it to you in both. All right, and so there's another method in here. You'll see up at the top, this is the method for averaging the grades, but there's another method called artist info, which takes in an artist name, and this is obviously a music artist name. And so it sets up a host name, which is musicbrains.org, and it sets up a query string, which is very specifically how you ask about an artist. So this is set up to deal with artists. If you wanted to code other stuff, you'd have to go read their page here on MusicBrains and figure out how to do other types of queries. In this case, I was just doing one query for for an artist name. But there's certainly piles of information on here. I'm doing this if you're trying to follow along at home. All right, so I'm getting in, they told me this is how I request a particular artist, and I put their name at the end of that query. So that's why I'm including artist name, and then HTTP 1.0 is usually going to be at the end of any query that you make. All right, so here we are in Java. I am creating a new socket to the host name on port 80. The host name will be musicbrains.org. And then I am doing a get output stream, and I am doing a print writer on that output stream so that I have the ability to write to them. And so what I end up writing is the query string, which is that weird get blah, 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 blah with the artist name in it. And then this particular service requires me to send two other things. One of them is a host name, which is their own host name. You have to say that to them as to who it is that you're trying to ask. And the other one is you have to identify yourself as to what type of web browser you are. This is just something that they require. It's not uncommon that people require this. It's called the user agent. So I'm pretending like I am a Firefox version 47 web browser. Why? Because that was the one that I could find a user agent string for quite handily on the internet. So this is just a string that I'm passing to them to say, I am Firefox version 47, and they're okay with that. You might be wondering, but you're lying because you're not Firefox 47, you're actually just Java code. And you're correct. I am totally lying and telling them that I'm Firefox 47, and they have no way of validating that as long as I give them a valid user string, which this is one, and that's why I had to look it up. They'll accept it. Yay for me. I can lie. All right, so I did a print line with the query string, which was that weird get thing, and that I knew to do because that's something that they told me to do. I have this print lines where I'm printing out the host name. That's just something that I have to pass to them, the user agent, and then I'm printing an extra blank line. Print line by itself prints one carriage return, but as you remember, I always have to send two carriage returns, so a print line by itself just sends another carriage return for me. And then I flush. Whoosh. At that moment, all of that junk got sent to their server, and their server generates a response. So I use scanner to read back in from my input stream, and I get something called return page. All right, and my return page is just a variable of type scanner, and I can say return page while it has a next line, I want to read it in and print it out. Okay, and of course I have to catch an IO in case something goes wrong, an IO exception, and that code is the Java code. I'm going to show you the same code in C# as soon as I find the appropriate window. Pretty much all of this part is the same. The only thing that's different is I'm using TCP client, and I'll just let you read through that on the screen. But I mean, effectively, I'm doing the exact same lines as I was doing in the other one. It's just that I'm using the C# code. And I'm just going to scroll down so you can see the exception handling. Again, it's printing that out. So I'm going to comment out the call to average grades, which was what I was doing earlier, and I'm going to uncomment something where I'm calling artist info, which is my method name up here, and I'm passing in the name of an artist, and I'm randomly picked Zed, who is an EDM artist if you've never heard of him. So I'm going to call that, and I'm going to get back a pile of text from that service on the internet, which has all kinds of information about Zed. Very specifically, the information I get back is in XML format, which I mentioned is one of the common formats that you'll deal with. And so you can see at the top here, it says XML version 1.0. It's encoded using UTF-8, and then it gives me all kinds of information. So like if we scroll down in here, it says the artist ID, and this is a big long string. That's a unique identifier. It is for Z. If I then were to make another call, which I can, where I pass his particular name, it'll give me back all of his albums and all of his songs and all of that type of stuff. But even just doing this query, it does tell me that this is a person as opposed to a group or a band. And then it tells me that their name is Zed. You can see that their gender is male. You can see their country is DE, which the country DE is Germany. And then you have a bunch of other stuff in here. So the name is Germany for the country. You can see lifespan information has not ended, so he is still alive and producing of some level. What city is he from? Apparently Saratov. And so on and so forth. He is a German-Russian recording producer, multi-instrumental songwriter, and he's also known as that name, which I'm not going to try and butcher, and so on and so forth. The point of this is a service on the internet which throws back a pile of information. And now I could parse all of that. I could use an XML parser object to pull all this in, and that would give me arrays of information that I could then pull data out of. The details of how you parse this is beyond the scope of this lecture, but you absolutely can do it. Just go look up JSON parser or XML parser in your respective language, and you'll find that there's something that'll take a blob of XML like this and convert it into a data structure for you. And then you can start walking your way through the data structure. And the data structure is probably arrays of strings and so on and so forth, which may have multiple layers in it. You may have arrays of strings, multi-dimensional stuff and all that. So that is the idea of making an API call. I should probably prove that it does work in the other language as well. So I'm going to comment out average grades in Java and run it over here, and you're going to get the same blob back. So the point of this exercise was to show you that there are things on the internet that you can connect to and get information back. Like, there's no way that you could have found that information locally on your server. This is something that you would have to go out and ask. And of course, this information gets updated constantly. And there's nothing magical about the word Zed. We can certainly type in Drake and rerun the command, and I will get back information about Drake instead of getting information about Zed, as I merge two names together. If Drake and Zed had a baby, they'd be Dreads. Okay, let's hope that the computing thing works out for me, because the life in comedy isn't looking too good. All right, so and now obviously you're getting information about Drake. So that is the idea of making a socket call, which is very similar to making a file call. You've now seen how you read and write from each of these things. There was another list of APIs that if you wanted to go play with, there are other ones on here. One of the ones that I didn't play with but looked pretty interesting and I thought might have been fun was iTunes. You can actually query songs and stuff from iTunes. However, that does say HTTPS. I don't know if it's also offered on HTTP, but whether there's stuff that'll tell you when you're going to die, there's stuff that'll tell you where your name is from, there's stuff that'll tell you jokes, there's stuff that'll give you memes, there's all kinds of cool APIs on the internet. Basically, every service that you have probably ever used, there's probably a API call somewhere that somebody provides. Usually you have to sign up for a key and you have to pass all kinds of other information to them. These were meant to be easy ones that you don't have to pass anything crazy to it, like XKCD comics and stuff like that. So hopefully that gave you an idea of some of the stuff that you can do with FileIO. You can read files, you can write files, you can talk to servers on the internet using the HTTP protocol. You can talk to servers on the internet using other protocols. They don't have to be HTTP. And again, all of that is beyond the scope of this class, but I wanted to get your appetite whet for all of that. So hopefully that gives you some great ideas, and that completes lecture number 18, which is the end of this module this week. So you'll get another video starting next week. I hope you guys all have a lovely week. Talk to you.